Content delivery networks, on the other hand, they're basically CDNs are service providers, and they're service providers that allow you as users to be able to do a large broadcasted stream, handle a large audience. For the most part, I would say the majority of private large-scale streaming is done utilizing CDN services today. Now, what a CDN does is a service provider that has all the bandwidth in the world that you're going to need, can generally handle, the formats, a variety of different server types for the type of users that you're going to have looking at your content. And they have the ability to transcode that content on the fly. So what you would typically do is you say, hey, I want to stream this presentation live, but industrial AV's doing so well, they got 1 million people, pounding down the doors outside to see this, and they're just not going to be able to get in. So we're going to pop it up to a CDN, and that CDN is going to rebroadcast it and even transcode it to other formats on the fly. Everybody can go to that IP address, and as many people as need to see it can see it live. That's the purpose of a CDN. Very useful service in this day and age.
What kind of numbers can they actually do? Thousands, billions?
For most applications, it's in the tens of thousands, but hundreds of thousands are certainly possible. I mean, there's no real theoretical limit. It's really dependent on bandwidth and the network architecture. So for the most part, what you see today is CDNs basically scaling to the needs. And they're really not hitting a theoretical ceiling of what they can do. Be interesting to see as the market progresses what happens there, because certainly we're still at the early stages of seeing that type of usage of service providers for streaming. So one of the things that's most important to understand about streaming technology and going out and implementing systems and using streaming in your life and your business is understanding the signal. I know many of you are familiar with the question of, well, how much bandwidth am I going to need? What's the image going to look like on my network? How big is that file going to be after I record this? So it's important to understand the composition of the signal and how it impacts that, because these are actually fairly easy things to determine, as long as you understand the components that go into the signal and how you have the ability to vary them. I was talking in the beginning about the conversion of analog to digital and how originally we did it to get better image quality and better sound quality, and today we give most of that up just for portability of signals. Well, this plays into that too, because that's what you're doing when you're efficiently delivering video. When was the last time you watched a high definition YouTube? You're basically getting that content to the end user, having it smoothly play, having it go over a variety of different network connections and different bandwidths. And the idea is the usability of the content as opposed to the quality. We often make that sacrifice. So you need to know how to make the sacrifices as you implement networks or as you implement streaming capabilities of any kind. So first let's talk about resolution. Display resolution is measured in pixels in each dimension, as most of you know. And here you have some of the common resolutions that we typically see in media today. The top three are all resolutions that you will find in the greater area of standard definition video. The bottom two, as you'll recognize, 720p and 1080p are today's standards for high definition video. And right there, rounding out the middle, 1024-768, which is about what you're looking at here, is again our typical XGA graphics, often referred to as VGA, although VGA was originally a 640 by 480 resolution. And keep in mind that each of these areas take a certain amount of that pipe that you need to move a signal down. So if you want to move something down at 320 by 240, it's going to be a lot smoother and allow a much higher frame rate and a lot less bandwidth requirement than if you're trying to cram 1080p down it. And it's interesting too, because as a manufacturer of streaming technology, we originally looked at some of the standard definition products that we were making as transitional bridge products. Now, high definition's here, high definition's taking over, and nobody's going to want these very much. In fact, when we introduced our digital media recorders on both standard and high definition platforms a few years ago, the high definition ones were selling, and we actually had discussions in our management meetings at Media Pointe about discontinuing the standard definition products. Today, our standard definition products sell as much or more than our high definition products. And so keep in mind, in the world of streaming media, standard definition is not dead, and it's not going away at the pace you see it in broadcast media. The reason for that is utility. It's all about the utility of the content. If you don't need high definition, why pay for the bandwidth? Why limit yourself as to the distribution capability that you have with that content? Let's talk about aspect ratios for a minute, just so you're aware of them. These are the two most common aspect ratios. Aspect ratio is pure and simply the dimension of a video image, its width by its height. 4:3 was the original film standard for 35 millimeter film that was then mimicked for NTSC video, and again for VGA signals on computers, the original 640 by 480 signals. 16:9, as most of you know, is our standard for widescreen televisions and standard for high definition television today. And many of our laptops, my laptop has a 16:9 screen, many of yours are starting to come out with that as we're working with rich media on our personal computer systems. Now here's a look at many of those common resolutions, and you'll see that the 4:3 format from VGA to what's 800 by 600, which was commonly known as SVGA, to XGA 1024-768, SXGA 1280 1024. These are all, and UXGA down here on the bottom, these are all 4:3 formats, whereas you'll recognize 720p and 1080p as your 16:9 formats. It's important to understand this. All too often you will see, even broadcasters occasionally, it's so annoying when you're watching a high definition broadcast and they have screwed up the aspect ratio by plugging in a 4:3 signal to a 16:9 pixel map or vice versa. And you see that as squashed or stretched media. You guys see it all the time, and it's something to be aware of when you're working with this type of content. The often overlooked area well, I'll get to the color depth in a minute. Let's talk about frame rate first. Frame rate, of course, is one of those things that all of you are familiar with as herky-jerky video over a network. So you basically got a variety of frame rates that you will typically see media run at, and this is something that you control in this world of streaming media. When you encode something, you decide what frame rate to run it at, and there's a huge difference. Common frame rates are 15 frames per second, 30 frames per second. Most people think of the requirement as 30 frames per second. We hear from end users and customers all the time, it's got to be 30 frames per second. We won't take anything less for their application. It won't work. Really not true, and really inefficient for a lot of applications. If you think about 15 frames per second compared to 30, and you think about these as data bits, it's costing you twice as much, it's twice as limited, it's twice as difficult to deliver when you're doubling the data. So let's look at some common frame rates. If you're looking at something off YouTube, you're typically looking at 15 frames per second. You've often seen 15 frames per second on video conferencing, although the sticker on the box says 30. Interesting, again, people think that anything under 30 frames per second they tend to believe will look poor, but if you go to a movie theater, you're looking at 24 frames per second, and even those videos and DVDs of movies that were originally shot in film are in fact at 24 frames a second. So as you can see, it's not quite as bad as you drop down that scale. Even NTSC is not truly 30 frames per second, although obviously we're splitting hairs there. But the European standard for video, PAL, and actually standard around much of the world, is 25 frames per second, and you'd be hard-pressed for most people to sit down and look at the difference between 25 and 30 and see it. And the reality is that obviously if it were an issue, most of the world, or half of the world anyway, wouldn't be using that standard. So let's quickly look at some frame rates just to give you an idea. Now, we don't have audio in the room, but you can hear it coming off my laptop. Can anybody tell me what frame rate that is? Guesses? Sorry? 4? 1? 1 frame per second. If I had candy, I'd toss it. But. Now, and it gets a little bit more difficult here. Now, what do you think we've jumped up to here? 9? 5? Five frames per second, correct. If I had a golf ball for you, I'd reward you. Any guesses? What we're looking at now? 15. Very good. So as you can see, this is very useful, and a lot of, this looks more typically if you're looking at a stream over the internet that you're going to see. And again, this is the standard for YouTube. And that's 30. You'll see a little bit of horizontal gradation of the image. That's really just my laptop scaling. It's not. That gives you an idea about what those frame rates look like. So you can think about that in terms of trade-offs when you're encoding content. Now, where I accidentally jumped ahead before, color depth. Color depth is the often overlooked area that we have to work with on our palette of encoding to decide how much data we're going to try to move, through this. So let's talk about color depth. Now, color depth is defined in bits per pixel. It's actually pixel depth. Depth is the way that we generally describe it in the industry. And it's the amount of bits of data used to describe a color. And it's measured by pixel, by second. So it's how many bits per pixel per second are used to describe that color. Higher number is going to give you, obviously, smoother and more gradation of images. You basically have gray levels. That is another way of describing it, that the various depth of the number is going to give you. And if you think about it, you have everything between 1 bit and 24-bit color typically that you can impact when you're encoding. You really don't necessarily need the color depth that you're capable of doing at 24-bit. So let's look at a few color depths and see what the trade-off is. We'll start down at the bottom, and you can probably tell this is a leaf, but other than that, it's not a very good picture. And that's 1 bit per pixel per second. Well, per second if it were a moving image, but that's basically what 1 bit is going to give you on this particular image in color depth. And you can see you've got about, 2 or 3 different grayscales that you're working with, and that's about it to define it. If we double that and go to 2 bits, you're still looking at, a black and white image, but you've got quite a bit more definition around it. You can see depth and shadowing that you couldn't see in the previous image. You double it again, and now you really see the colors start to come out. You can see a lot of gradation in the color, in particular, where the blacks and whites are starting to smooth out. But again, we've doubled the amount of data that we are now assigning to color depth. We'll double it one more time, and you can really see the image come alive. Now there's still, and it's kind of hard to see on this projector, but there's still a certain amount of granularity and gradation in some of the, particularly the out of focus areas. But this, for all intents and purposes, is a fairly acceptable color level for a lot of content that you might be recording. And depending on what you're recording, you might not be able to tell the difference. If you're recording a PowerPoint, for instance, with big, bold colors, you'd be hard-pressed to tell the difference between 8-bit and true color. If you've got something that has a whole lot of detail in it, that's when you want to allocate more of your bit rate, and there's true color there. So you can see very little difference between 8-bit and true color. Yet
This is true color.
24-bit is what we call true color.